The concentration of anesthesia in a person's bloodstream can be modeled by the function C of t equals 35t over t squared plus 6, where C is given as a percent and t is in hours. A graph of C is shown below. So A, what do you notice about the graph, and what do you wonder? So the notice is just, well, anything. What do you notice when you look at that graph? So there's a relative max. Okay. What else do you notice? It increases a lot at the very beginning, and then it is a decreasing function from then on, right? It continues to decrease. So that's what they said they noticed. There's an initial spike and then a decrease over time. What's something you might wonder about this graph? What are the labels for the X and Y? So, yeah, they didn't label them. They did tell us, though, that T was hours. And this is the percent of concentration of anesthesia. I don't even know how to label that. But that's the percent of anesthesia in their bloodstream. So their bloodstream contains upwards of 7% of anesthesia, and then it slowly tapers off. Something else you guys might wonder?
Did they ever touch a zero?
Yeah. When does anesthesia go away? Right? It looks like it's going to kind of steady off. Will you ever get rid of all of it? That's a good wonder. That's what they did. B, what is the concentration of anesthesia after half an hour? So what's time going to be? Time's going to be 0.5. So from the graph, we can get an estimate. I would say it's going to be about 3. Right? That's just an estimate. But I could find exactly what it is by plugging in to the equation. So if I plug in, I'm going to get 35 times t, which is 0.5, over 0.5 squared plus 6. And so if you get a calculator, you can plug that straight in. That's going to be 17.5 over 6.25. And they would not give you that without a calculator. That would be very mean. Somebody tell me what they got, because I don't have my calculator. Or don't, that's fine. Thank you.
I was just going to make sure somebody else did,
Okay.
because I didn't know if anything did.
It is 2.8%, which goes back to what I said, close to 3. So that makes sense. Then it says, what's the concentration of anesthesia after 24 hours? So you can go up there and highlight your function and then just replace the 0.5s with 24s. Just tell me when you get it. 1.443%. So you still got some after 24 hours. Still some anesthesia in your bloodstream. What about 48 hours? Everybody getting these? Or we have any problems there? Questions on 2. At a concentration at or above 5%, how long should the surgeon wait to start the surgery? How'd you get that? Yeah. So if you look at the graph, you could think about if I'm looking for 5%, then I'm really thinking, well, when the y value is 5, how long does it take to get to that point? Remember yesterday when we did the two graphs, we did the y equals 700 and found where they intersected? It's the same idea here. Right, where are we at 5%? Well, it looks like it's when t is 1. So the surgeon should wait an hour. And then how long should the surgeon, or how many hours is the anesthesia effective for?
5 hours.
That's correct. So that's kind of a little bit of a trick, right? They should wait 1 hour, and then it's effective until t equals 6. So you could subtract those from 6 to 1. So we could say it's effective for 5 hours. So they need to have 1 hour wait time. That's what my paper says. 1 hour wait, and then it's effective until t equals 6, which means it's effective for 5 hours. Questions there? After many, many hours, what do you anticipate will happen to the concentration of anesthesia? It will continue to decrease, and eventually we suspect it'll go to 0. So we suspect eventually it will go to 0. And so if I had to write that very pre-Cali, fancily, am I even saying words now? If I want to make it sound mathy, what am I talking about after many, many hours? Limit notation. We're talking about when the x's, or in this case, the t, gets really, really big. So we would say the limit as t approaches infinity of, my function name this time is c of t. So the limit as t approaches infinity of c of t is what? 0. So far, our end behaviors have all been positive infinity to negative infinity with a polynomial. But here, this is different. Now the limit is approaching a number, getting closer and closer to 0. So that's interesting. 5. For large values of t, which grows faster? The numerator of c of t or the denominator of c of t? So let's look at what c of t is again. 35t. That's the worst 5 ever. Let me redraw that. 35t over t squared plus 6. So think, if I plug in a really big number, which one's going to grow faster? Why? Does everybody follow that? Because the denominator has a higher power, it's going to win at very extreme values. So that's what you can kind of think about. Here's what they say. They say the denominator because it's getting squared. So I'm going to say the denominator because its degree is greater than degree of numerator. When this happens, when the degree of the denominator is greater than the degree of the numerator, we have a horizontal asymptote at y equals 0. So you guys said you were familiar with horizontal asymptotes, what it's approaching at very large values. And hopefully you remember that rule. If the degree of the denominator is greater than the degree of the numerator, it's always a horizontal asymptote at y equals 0. Okay, 6. How is your answer in question 5 related to the long-run effect of anesthesia in your body? So if we relate it to 5, the denominator is growing faster and faster and faster. So what happens if this number gets bigger and bigger and bigger? This number is also getting bigger, but at a slower pace. So the fraction overall is becoming a smaller and smaller fraction. Just think about it. If this was 1 over 2, that's 0.5. And if they grow to be 2 over 5, it's 0.4. 3 over 10 is 0.3. We're getting closer and closer to 0 because this one's growing faster. That's what they're wanting you to put together. When the denominator grows faster than the numerator, the overall number, the overall fraction, gets closer and closer to 0. And so some version of that. I'll give you their big, long, fancy wording, but I don't want to write all that. I'm just going to be honest. Here's what they said. Because the denominator is growing so much faster, the fraction expression for C of t is getting very, very small. In other words, closer to 0. So it says, determine the horizontal asymptote of y equals 2x minus 4 over x plus 3 by evaluating the limit as x approaches infinity, both positive infinity and negative infinity. And then, does this function intersect its horizontal asymptote? And if so, at what point? So I don't know how much, when you guys learned about horizontal asymptotes, so a vertical asymptote that goes straight up and down, the graph can never cross there. Because if it crosses a vertical asymptote, then that means that x value has occurred. But if you think about where vertical asymptotes happen, so this is kind of a throwback. When we first started talking about domain of a polynomial, I said there were 2 possible reasons the domain might not be all real numbers. Do we remember what they are? 2 things that you can't do in math. Divide by 0 gives a problem. Square root of a negative gives a problem. Vertical asymptotes are a result of a divide by 0 error. There are 2 things that can happen if you divide by 0. You get a vertical asymptote, or you get a hole in the graph. And we'll look at holes tomorrow. Those are the only 2 possible outcomes with a divide by 0 error. So because we're looking at rational functions, we could have divide by 0 errors. And so my point is, for a vertical asymptote, if it exists, that's because that x value can't happen because we're dividing by 0. So we never cross a vertical asymptote. Never, 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 never. Can't happen. Horizontal asymptotes are different. They talk about what the graph tends to at its extreme values. So as x gets really, really large, the y values are going to get closer and closer to that horizontal asymptote. And same thing as x gets really, really small, the y values get closer and closer to that horizontal asymptote. But just because it tends towards the asymptotes, in the middle, where it's doing all its funky jazz at a vertical asymptote, it can cross them. So this graph, I'm just going to make one up. It could be down here. It could come up above the horizontal asymptote and then get closer and closer to it as it goes towards infinity. And then say that this was the asymptote here. Or sometimes it never crosses it. It just gets closer and closer towards infinity. But it can cross, is the point. So that's why it's asking, does this one cross? So hopefully you've graphed it. I know I've talked a lot. So this is what the graph looks like. Is everyone good there? In standard view. So what are the y values getting closer and closer to? Yeah, it looks like this one's going above 1. Right, getting closer to 2. This one might also be getting closer to 2. A way you can tell is go to your click second table set. And let's just start the table at 1,000. Right? If the x is really, really big. And then click second graph to pull the table up. And does it tell you what the y values are when x is that big? They're fractions, okay. If you click on the fraction, I think there's a way to make it a decimal. Give me just a second.
I went to mode.
Yeah. That's where I was looking, was mode. I think if I go mode classic instead of math print, nope, that doesn't work either. Tell me what you did in mode.
I went to answers and I just put this.
Where's Ant? Where do you see that?
It's the second one.
Oh. Yep, good call. Good call. Great call. Everybody hear what Anthony said? If you go to mode and then go to, there's a thing that says answers. You can either be auto or decimal.
How do I get it to be smaller?
Smaller. You mean like look like mine?
Yeah.
Zoom 6.
Okay.
Always Zoom 6 gets you that normal box that's from -10 to 10. So what were the, as the x's were getting really big, what's the y's getting close to? 2. Right, it should be 1.99 whatever, right? We're getting really, really close to 2. So the question here is, determine what does the limit approach as we get to positive and negative infinity. The answer there is 2. So the limit as x approaches infinity of, we're just calling it y, aren't we? Is equal to 2. And the limit as x approaches negative infinity of y is also 2. Everybody follows that? And we'll talk about why later. Right now we're just exploring. Right? We'll talk about how you can do it without a calculator. Because I know that without a calculator.
What is, like, I pressed trace and went, like, on the lines, and it says the x is, like, 10.
Yeah. Because your graph can't go any farther. Well, it looks like you can go over if you keep.
It just keeps going up, though. Oh, wait, no, it doesn't. My fault.
We were talking about, so what we were looking at was the table. So if I go to second table set, and we were saying, let's get a table of values that start at 1,000. Sorry, I should have probably put this up on the. And so in this table, as the x's are really big, up in the thousands, you see how these numbers are getting closer and closer to 2?
Yeah.
They may not cross it, and at that point, they're probably not going to cross it. The place that they normally cross horizontal asymptotes is around the vertical asymptote. Somewhere in here is where they normally do. So because we're way out there, I don't think it's going to cross it at that point. It's just going to get closer and closer to it forever. Now here's how you can know if it does cross it. I'm interested in the y value being 2. Everybody follows? Because if the function crosses the horizontal asymptote, then y has to be 2 at some point. So set y to be 2 and solve it. So does 2 equal 2x minus 4 over x plus 3? How would you guys solve this? I know what I would do. Hopefully, since I taught some of you guys, you'll do what I told you to do, but you probably don't even remember because it's been a while. And so if I was working this, I see a fraction equal to a number. I always make it a fraction equal to a fraction and cross multiply. I think that's the easiest way to do it every time. So 1 times 2x minus 4 is 2x minus 4 equals 2 times x plus 3. You have to distribute 2x plus 6. Is everyone okay with me doing that? And now then we've got x's on each side. So move one of them to the other side so I can subtract 2x on both sides. Now the x's go away. So I'm left with a math statement, negative 4 equals 6. It's not a true math statement. So, no, it never crosses. See, I tested. Where does y equal 2 in this? Well, it never did, right? I got a nonsense answer. Okay, so my first question on number 2, let me take a picture of it. Did we find the horizontal asymptote? What was it tending towards? The horizontal asymptote is an equation of a horizontal line. Y equals 0. So the horizontal asymptote is y equals 0. I bring that up because, why do you think I bring it up? Because every year people just put the number. But it's an equation of a line. Y equals the number. Okay. Anyways, that's just me being nitpicky. But something that you'd probably miss if you did it on the exam. Does the function intersect the horizontal asymptote?
Yes.
It did. Where at?
X equals negative. That's what, I don't know if that's right. That's what I got.
That's not what they got, but they may have a mistake. So let's work it out. If y is 0...
I don't know if that's right. Oh, it's positive 2.
Okay, that's what they had.
I'm just...
I should put this over 1, cross multiply. 0 times x squared plus 3 is 0. So 2x minus 4 equals 0. Add 4. 2x equals 4. So does the x exist where y is 0? It does. So it does intersect with it at 2, 0. And so if you look at your graph, that means you should have an x-intercept this time at 2, 0. It should, I don't know if it crosses, if it bounces. I don't know which, I would assume it crosses because it only has a multiplicity of 1, right? Can you see if it crosses?
Well, it kind of just stray across on that x-axis. I'd have to zoom in more.
Yep. So a way you can do that is you can click trace, and it'll stay on line with it. So you can see your y's are negative, and then they become positive.
Makes sense.
And then it's fixing to start turning back down. You see how your y's are getting bigger and bigger?
Yeah.
And then they start getting smaller and smaller again. It's going to get closer to that 0. You guys follow what? Do I need to pull that up? I know I just did that on one calculator. If I trace it and click, like, go along the graph, just go sideways, it'll stay on the function. And you can see the x's, or when x is like 0 and 1, the y's are negative. And then as x gets to 2, And above 2, it crosses. The y's become positive. And the y's go up a little bit, and then they start back down, and they're going to get closer and closer to 0 forever. Right? They don't cross again. Okay, on 3, what did we get for the horizontal asymptote? Phi equals 1 is the horizontal asymptote. Everyone good there? And then did it intersect with the horizontal asymptote? Well, let's see. If I do 1 equals x squared plus x minus 2 over x squared plus 3x minus 10 over 1 cross multiply. So I'm looking, where does x squared plus x minus 2 equal x squared plus 3x minus 10? So get all your x's to one side. So subtract x squared. So those go away. I'm going to subtract x. That's the way I would do it. And so those go away. That leaves me with negative 2 equals 2x minus 10. And hopefully you can solve from there. Add 10 to both sides. So 2x equals 8. So I got x equals 4. And so the point 4, 1 exists. So that means it crosses there. So it does cross the horizontal asymptote. And it's at this point, 4, 1. Questions there about how I did that algebraically?